aluminium is a very useful metal. It is lightweight because it has a very low density, and for everyday applications it is very unreactive. So it's really good for things like food packaging, for aeroplane bodies because it's lightweight, and things like that. Aluminium is a metal, so it has all of the characteristics of a metal. It conducts electricity, it is malleable, etc. Aluminium, however, is, if we take a look at the reactivity series, surprisingly high in the reactivity series. It is actually quite a reactive metal. Yet I've just said that it's useful because it's unreactive. So what's going on there? Well, aluminium has a unique property. When it is made, when it is extracted from its ore, it is exposed to the atmosphere, and as soon as it's exposed to the atmosphere, a single atom thick layer of aluminium oxide forms on the surface of the aluminium. This gives it a protective layer, preventing anything else getting in and making it, for practical purposes, very unreactive as a material because of this protective oxide layer. Because aluminium is quite reactive as a metal, if you strip off the oxide layer, it can be quite reactive. That means that we can't displace it very easily. For some other metals, such as iron, go and have a look at my iron in the blast furnace video, we are able to extract it from its ore by using reduction with carbon. We can't do that with aluminium because, as we can see, aluminium is higher in the reactivity series than carbon is. So we can't use carbon, we can't use a blast furnace. So how do we extract iron from its ore? Well, the main ore of aluminium is mostly aluminium oxide. It has a name, it is called bauxite. Commit that name to memory. It will come up on your exam, guarantee it. It is a very, very common question. It is a way to get 1 mark. The main ore of aluminium is bauxite. B-A-U-X-I-T-E. Anyway, so how do we extract aluminium from bauxite if it's too reactive to displace with carbon? Well, we have to use electrolysis. Electrolysis, again, if you're not sure about electrolysis, I've got a couple of videos on that. You can go and watch them. But the short version is that electrolysis is the separation of ionic compounds using electricity. So let's go through the steps of the electrolysis of aluminium oxide. Step 1, think about electrolysis. It's got to be molten or it has to be aqueous. Problem, aluminium oxide doesn't dissolve in water, so we have to melt it. Another problem, very high melting point. So that means that we'd have to spend a lot of energy, therefore a lot of money, melting it. So we don't. Well, we do. But what's done is it's mixed with this substance called cryolite. Cryolite lowers the melting point of aluminium oxide. In an exam, if you are asked the purpose of cryolite, it is to lower the melting point of aluminium oxide. So now we have this molten mixture of aluminium oxide and cryolite. Cryolite does not take part in the reaction. So we then stick it into an electrolysis cell, which looks a little bit like this. Take note, the cathode is actually lining the walls of the electrolysis cell. It doesn't go in the top. The anode goes in the top, the cathode lines the walls of the container. They are both made of graphite, which is a form of carbon, because graphite is inert or unreactive and it conducts electricity. So it's set up like this, the current is switched on and electrolysis occurs. So if we have a look at what happens at each of the electrodes, and then we can look at the products. We'll start with the cathode. These are the ions that are present in aluminium oxide. There's no hydrogen, there's no hydroxide because it doesn't have any water in it. So the aluminium is attracted to the cathode because aluminium has a 3+ charge. When it gets to the cathode, electrons are added to it. It is reduced, reduction is gain of electrons, in order to form aluminium metal, the element. At these temperatures, it's about 900 degrees Celsius, aluminium is a liquid. So the liquid aluminium is, there's a tap, it comes out the bottom of the container. Here is the half equation for that. Notice that we're adding electrons. Okay. At the anode, the ion that's attracted to it is oxygen, or the oxide ion, I should say. So the oxide ion is 2 minus, and what happens is it is going to lose electrons. It becomes oxidized. So it's going to lose electrons and it's going to form oxygen gas. Here is the half equation. Notice that oxygen gas is a diatomic element. So you have to balance the equation like this. So far, the products that we have are aluminium, liquid aluminium metal, and oxygen. However, oxygen is not the final product of this electrolysis because I mentioned before, the electrodes, including the anode, are made of carbon, graphite. Oxygen and carbon at high temperatures, like this, will react. So what happens is the oxygen reacts with the carbon in the anode and produces carbon dioxide gas. This wears away the anode, and the anodes have to be replaced periodically. That is a question that comes up in the exam quite often. Why do the anodes have to be replaced? Because the carbon reacts with oxygen to produce carbon dioxide. So the products of this electrolysis are liquid aluminium and carbon dioxide gas. Okay. There may be some oxygen as well, but they're the two products that we need to know. So to sum up, here's the half equations. You need to mix it with cryolite to reduce the temperature, and you need to electrolyze it. Okay. Thanks for watching.